Okay. We're going to be simplifying radicals with variables. You have been simplifying radicals with just numbers inside.
Yeah.
Now we're going to add some variables, okay?
Great.
So we're going to review first what you were doing before so we can kind of use that. So if you were told to take the square root of 20 and to simplify it,
2 and 10.
okay? So we break that down into 2 and 10.
And then 2 and 5.
2 and 5. So this could be written as 2 times 2 times 5, right?
Mm-hmm.
And then you're going to take out the double, right?
So it'd be 2, and then the radical times 3 and 5.
Okay.
Yeah.
So if we had a variable this time, instead of a number like 20, if we put in the square root of x to the 6th power, okay?
Oh,
This
so
would be
I know it. I know what to do.
x, 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 and x. There'll be some doubles, right?
Yeah, that and that. Oh, so it's just gonna be x 3x.
Not 3x, but x to the third power, okay?
Yeah.
So I'm hoping you're going to find a pattern to go from that 6 down to that 3.
Oh, just take that in half when it's the half.
Let's see if that works on all of them. So if I had x to the 4th, the square root of that, we're going to have x and x and x and x, right?
X squared.
X squared, right? So yes, you're going to
Yeah.
take it in half. The trick comes when I don't have an even number. What if I had x to the 5th?
Then it'd have to be like the little 3 sign above, right? Because since it's an odd number, it can't be under the it would have to be with like the little 3, whatever that is, when you have
In the
like,
front up here? Like
Yeah,
there'll be a little
yeah.
3 there? Okay, let's check. Let's check. Let's do the same thing we just did up there. Let's go x and x and x and x and x. Do we have any doubles?
Yeah,
Right here. And we have this. What do I do with that extra one?
you leave it underneath there.
We leave it underneath there. So we'll have x squared, but we'll have one left inside.
Oh, okay.
So does that make sense?
Yeah.
Okay, so how we know we can jump to this one really quick, go from the 4 and just half it. How could we jump down here?
2 times 2 is 4 plus 1, so you'd have so you'd like half the 4 with the 1 underneath.
Yes. So if I had like x to the 7th, and so
Okay, hold on, I gotta think.
okay,
X to the 3rd with
Okay.
1 underneath.
with one left over. Okay, good.
I like this.
Let's do some. Now that let's do one more. We'll do x to the 13th.
Oh no. Okay. 12 would be the nearest.
Very good. The nearest. That's right. We're going to go to the nearest the nearest even would be the 12th.
So it'd be 6.
Very good. X to 6 because we took half of it.
With 1 underneath.
One left underneath. Okay. So what if we now are going to do cube roots?
That's what I was trying to say earlier.
Yes.
It was cube.
Yes. So if I'm going to do y, we could have picked x or y, and I'm going to do to the 9th, but this time I'm going to do to the cube root. So this time we have to take out triples.
Okay.
Okay.
So this time you would have all. Can we just for this one write all the y's?
Let's see what we can do here. All the y's. So I'm going to have to do little y and y, 2, 3, 4, 5, 6, 7, 8, 9.
Okay.
Okay.
So then you'd have 1, 2,
I have-
3. Oh,
yeah.
just be y to the 3rd.
Yes. So I
So
have
you
here.
take half of it again.
Not half of it again. So this time we get y to the 3rd. How did I go down from 9 to 3? Because it's not half.
Oh, that's right. But isn't 3 times 3 9?
3 times 3 is 9.
Oh, right. But that isn't. Okay. You're multiplying it.
The 3 times the 3 went up to the 9, but how do we go backwards from 9 down to 3?
Oh, you divide.
Let's see if that works with this one. So if I went y to the 12th, and I'm taking the cube root of that,
It'd be y to the 4th.
y to the 4th, because we're going to take 12 divided by the 3. That's exactly right. So let's go back to a couple of these. When we had a square root, we did it in half.
Mm-hmm.
When we did cube root, we do it into third. So this is kind of like a fraction. It is. It's a fractional exponent. Okay?
Wow, that sounds scary.
That sounds scary. So this is whenever we have a root, a cube root or a third root or anything, we're actually dividing the exponent by that amount.
Oh,
Does that make sense?
Yeah.
Now let's do a little bit. Are they going to do? What else are they going to do here? Let's do one where it's not a perfect, like 12. What if it was 11? Y to the 11th,
No.
and we do to the third?
You'd have, well, 10 is the close, but that's not, yeah, 10.
But 10's not a perfect for the third. It's perfect for the half, but not perfect for the
So
third.
it'd be y 5 x and a half.
Okay, let's do this one. Let's just do all of these. We're doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Here's my triples.
So it'd be y to the third with y to the second underneath.
Y to the second underneath that. So I have a 3 to the third power is 9. And I have 2 more.
Oh,
Okay, so we're still gonna divide just like we did. We're gonna take 11 divided by 3. How many times does 11 go in there? Should be 3 go into 11.
3 would only go in 3 times.
3 times. That's why we got a 3 right there. What's our remainder?
2.
2. That's why we got a 2 there. Oops, and there. Okay, so let's try again.
Okay.
Let's do y to the 14th. No, let's do 16th. Cube root.
Okay, so then here you'd have 3 goes into, okay, so 5.
Okay, so what do I do with the 5?
You put y to the 5th.
Good.
And then cube root with y squared. No, not squared. Not squared. Y to the third. I think. Hold on. 5 and 3 is 15. So that's not going to work. You're going to have more than...
So if I did this, I did 16 and then I divided it by 3. You said it goes in 5 times, right?
Mm-hmm. So
And so that's 15.
With one left
With
over.
1 left over. So then I have like a little 1 or not.
Not. It's just that.
It's just that.
Okay.
Okay?
Yeah.
Okay. So let's do... Because the cube ones are a little harder. Let's do a little bit more. Let's do y to the 20th cube root.
Okay, let's see. 3. Okay, so you'd have 3 goes into 20 6 times. So y to the 6th, and that's 2. So then y squared.
Very good.
Yay! Okay, I like
Got
these.
it? Okay. And it looks as if they're only giving you squares and cube roots. And so we're not going to go up to 4s and 5ths, at least
Okay.
yet. Right now, that's what they're doing. Okay?
Yeah.
So basically, whenever you do cube roots and square roots, you're dividing the exponent, and what's left over, or the remainder, is the exponent, what's left inside.
Okay.
Okay? All right. Good. We're done.
Yay! I like that.